You saw an example of static routes in previous sections, but as I told you, I cannot make it scalable. Whenever my network starts growing, I cannot manage all those static routes on all my routers. So I start doing something else. I want to add my routes to routing tables dynamically. And several protocols are available to do this. For example, the simplest one is RIP, and I'm going to talk about RIP in this section. RIP is, an abbreviation for Routing Information Protocol. And this is a simple protocol that uses the hop count as its metric. For example, if I want to reach router 4 from router 1, I use one hop to reach router 2 and another hop to reach router 4. So router 4 is 2 hops away from me and its metric will be 2. And it's a very simple protocol. It has two versions, version 1 and version 2, and version 1 has some very simple configuration. Version 2 will add some modifications. For example, version 1 updates are sent using broadcast, but version 2's updates are sent using multicast. And I'm not going to talk about multicast in CCNA level because this is CCNP level, of course, I guess, topic. But if I need it, I will talk about that. Okay, let's go to router 1 and start configuring RIP to see what it is like. And I want to use a very simple configuration to do this. I go to privilege mode using enable command. I go to configuration mode using configure terminal command and start RIP process using router RIP. And RIP has only one instance. It doesn't have several instances. It cannot run in several processes. I only run one process of RIP on each router. I hit enter. And now I should tell RIP protocol which interfaces are participating in RIP process. And to do this, I introduce them using a network range. So I type in network command and tell the router that this network and this network and this network will work in RIP process. But the problem with RIP is it only accepts classful IP addresses. So if I type in 10.0.12.0 on router 1 and type in enter, it won't accept that command. It will just take the 10 from this because 10 is a class A IP address and class A IP address has only 8 significant bits for its network ID. So if I try to show the running config and see the section of router RIP, you can see that the only thing that is possible here is to add network 10.0.0.0. You should wait for a second and you can see this right now. Okay. Now I want to see this configuration in effect. So I show IP protocol result command and you can see that here I have two interfaces that are in RIP process, that is pass 00 and pass 01, because both of these interfaces are in 10 network. And you can see some very interesting information here that are very important to you. You can see that the updates are sent every 30 seconds. That means every 30 seconds I send my routing table to the other routers. And this tells the next update is 7 seconds from now. That means in that specific moment of time, I have passed 23 seconds and I would wait 7 seconds to send my next update. And here I have another pieces of information. This says a route will be invalidated in 180 seconds. That means if a route is not refreshed in this update, I will wait 3 minutes for that. And after 3 minutes, I will invalidate that route. That doesn't mean that I delete that route from my routing table. I just mark it unroutable, or I just mark it is going to be deleted. And the hold down value is the same as invalidate value. And whenever I mark a route as deleted, I will wait another 60 seconds, another minute, and then delete it from my routing table. If that route is refreshed again, I will not delete it from my routing table. So I wait 3 minutes, I mark it deleted, and wait another minute and delete it from my routing table. This is the meaning of this line of information in to show IP protocol command. And the next pieces of information are here. I sent my routing information using version 1. That means I sent them using broadcast. Because I haven't configured version here, I won't send them using version 2, and I will go by default by version 1. But as you can see, I accept version 2 updates as well as version 1 because some routers may have version 2 updates sent through their interfaces. Okay. And you can see that the network that I'm sending information about that is just 10.0.0.0. Okay. Now, I do the same configuration on other routers. Go to configure terminal router RIP and network 10.0.0.0 here. I go to router 3. Here I have another network available. Configure terminal. Let's see the networks that I have here. That's 172.16 and 10. So I start router RIP process. I add network 10.0.0.0. This is a class A network, so the first byte is the most significant part. I add network 172.16.00. This is a class B network, so the first 16 bits will be significant for RIP process. Now I do the same configuration on router 4 because this has the same networks as router 3. So I type in router RIP, I type in network 10.0.0.0 and network 172.16.0.0. And now I have routing table populated on every router. So I go to router 1 and check the IP route table, and you can see that every route is accessible here, and those routes that are added to my routing table using RIP process are flagged R here. So let's check the accessibility. I ping 172.16.34.4, it is accessible. I ping 10.0.24.4, it is accessible, and everything is working just fine. Now I want to add some more interfaces to my router. I want to add for example, loopback interfaces to my router, and I will add, for example, class A IP addresses to them. I type in interface loopback 0, and LO is quite okay to distinguish loopback interface, and 0 is the number that I assign to that loopback interface. Now I want to add an IP address for that. I type in IP address command, for example 150 and 111 255 255 255 0. And now I add this network that is a class B network to my network to router RIP process. Router RIP network 150.1.0.0. And let's check the configuration of RIP up to now. To show run section router RIP, and I have this network added again. Let's see it in a second. Yes, that's it. I do the same thing on other routers. I go to router 2, I add interface loopback 0. IP address will be 151.2.2 255 255 255 0, and you can see that these are in different subnets. I go to router RIP process and add this command. On router 3, I do the same thing. I add this command first and then add interface loop like 0. The order of operation is not that important here. 150, 133, 255, 255, 255, 0. And on router 4, again, I have this. Loop like 0, IP address, 150, 144, and 24 bits of mask. Now that I have added these networks to my web process, let's check the reachability from, for example, router 1. Show IP route will tell me that I have 150, only 1, and a summary address to 150.100. So if I try to reach 150.122, you can see that this is unreachable. And this is what we have here, and I want to talk about this in next section to show you how I can make this destination reachable.